SDN is one of the most important technologies in advanced networking today, and the reason for that is it makes networks more flexible, more powerful, more accountable, and allows you to do more services than you could with the traditional networks. So it's very important, and it's spreading throughout the world of networking very fast. NFV is, to me, a subset, and that relates to a general premise that you can make about all of information technology, which is that every major revolution forward, every major advance has been based on the idea of doing another layer of abstraction, another layer of virtualization. And what this does is it allows you to abstract functionality. So instead of having, for example, what they call a middle box, which is a physical device within the network that does one function, you can abstract that to software and have that, for example, in a cloud. So you don't have to clutter up your communication center with lots and lots of middle boxes the way it happens now. But instead, what you do is you abstract those functions by virtualizing them to place them wherever you want.
As you know, networking is becoming a commodity, so everyone is looking for revenues, and revenues comes from services. So of course in Europe we have very important stakeholders in the networking community, large companies like ARCCN, Alcatel-Lucent, and everyone is looking on the one hand in a way to cut costs, operation costs, and on the other hand to make more revenues out of the infrastructure. So it's clear that SDN on the one hand, but I will say more importantly, NFV is a very, very important topic in Europe. And even though if you look at the 5G program that the Commission is developing within Horizon 2020, the framework program, then NFV has a very important part.
SDN is exciting the research community greatly. It poses both some wonderful opportunities and some very challenging issues that have to be addressed. Certainly the European community is interested in seeing where it goes. There's both, there's a lot to it. It's not one simple technology. So there's a lot of excitement, but people are also starting to recognize that there's going to be a lot of work. It's a very complex issue, the way we build our networks today, and unbuilding them and creating more elegant, efficient networks is going to take some time. So there's a lot of work ahead for us.
So in the Genie project in the United States, we're very interested in learning about new methodologies for programming deep into the network and for changing network behavior under experimenters' control. So that
it is extremely important for Russian federations nowadays. Why? There are several reasons for that. The first one is because right now the network architecture under the big changes all over the world, and people all over the world working on the architecture of the new internet. The second, this situation gives Russian Federation a great opportunity to develop its own solutions and let me say get some part of this market, because so far Russia just consume the equipment solutions which came from the West. And this is the big problem, not only from the economic point of view, it's also a big national security problem, because right now networks, informational system, it's a point of national security, and right now people talk about the national sovereignty of information space of the state. And the third point is, it doesn't matter will Russia be able to use these 3-5 years which it has in order to develop its own solution or not? In any case, we will need the Russian engineers who will be able to apply, to design networks which was developed on the basis of the new network architecture. So this is quite important for the Russian universities to possess these technologies, solutions, approaches, participate in idea exchanges, so this sort of things.